Hey everybody, it's Mr. N here, and here is another FTC AP test type problem we're going to review. And this one's good because I've added a bunch of different things that they can ask. So let's take a look at this. And on this problem, it says the graph of the function f shown below consists of 5 line segments and a semicircle. Let g be the function given by, and here we go. It's the integral from 2 to x, so we're starting at 2 of f of t dt. So what it's telling me is that this is a derivative graph. So this is the graph of f right here, which is the integral. When I integrate this, I get g. So the first thing that I like to do when I see problems like this is I just like to break these up and find the areas, because we're going to eventually have to do these in all these FTC type problems. We're going to have to find the areas under the curves. So what I'm going to do is I'm going to find the area here for this part right here, and this triangle has a height of 1, 2, 3, 1, 2, 3, 4, and a base of 2, so that's 8. Half of that would be 4. Then I've got this triangle here that's 2 and a height of 2, so that's 4 divided by 2, so that would be negative 2, and negative because it's below the axes. Here's a semicircle with a radius of 2, so it's 1/2 pi r squared, so the radius is 2, so 4, and then 1/2 because it's a semicircle, so this whole thing is 2 pi in here, but I'm going to break it up and say that this half is pi and that half is pi. You can certainly write this as 2 pi. And then over here, this is 1, 2, 3 by 1, 2, 3, 4. So that would be 12, and half of that, so it's below the axis, negative 6. And then this region in here would be 1, 2, 3 by 2, so 6. Half of that would be 3. So that was the first thing I did. I went ahead and found the areas of those regions. All right, so let's take a look at this first problem. It says, for each of g of 0, g prime, g double prime of 0, find the value or explain why it doesn't exist. All right, so let's take a look at what we're going to do. And I'm going to just slide this up just a teeny bit here. So we know that g of x is equal to the integral from 2 to x of f of t dt. Okay, so we're starting at 2, that's our starting point, and we don't have any other initial conditions, so we can go with this. G of 0 will be the integral from 2 to 0. Well, I have to change that and say that'll be negative the integral from 0 to 2, so we're going to flip that integral around, and which means I need the area from 0 to 2. So from 0 to 2, I look over here, from 0 to 2, and that area is pi. So this is going to be negative pi. Then we're going to go ahead and find g prime of 0. G prime of 0, well, what am I looking for? This is the derivative with respect to x of this 2 to x, right? So those go away, so then it's just my f of t in this case. So I just want the value, is what this is telling me, at 0. So just need the value at x equals 0, and I look at that, and that has a value right here of 2. So this will be equal to 2. So the first one was negative pi, the second one is 2. Now moving on, I need g double prime of 0. So this is like taking f prime. So now I'm looking for the slope at x equals 0. So the slope at x equals 0, I take a look at here, and that's a horizontal tangent, so the slope is going to be 0. So this is a horizontal tangent, so this g double prime of 0 is going to be 0. All right, let's move on to part B. For what values, I'm going to slide this up again, for what values of x in the open interval from negative 6 to 8 is g increasing, and explain? Well, they're asking here where g is increasing. Since I'm looking for g to be increasing, that happens when the derivative is greater than 0. So I need g prime to be greater than 0. That's when it's increasing. So basically I'm looking at the slopes of G, which is the graph of F, and that means I need F of t to be positive. And that's when G would be increasing. So on the open interval, where will it be positive? So let's take a look over here. We've got above the axes from -6 to -4. Then we've got above the axes from -2 to 2, it's all above the axes, and then again from 5 to 8. So let's write all that down. We've got this from -6 to 4, -6 less than x less than 4, union -2 to 2, and then the next one is 5 to 8. You can certainly write these as -6, 4, union -2, 2, union 5, 8. You can certainly write it in that format as well. Okay, moving on. Find all values of x in the open interval 6 to -8, which G attains a relative maximum, and justify your answer. For part B, explain your reasoning was right here, by the way, just where we said that it needed to be greater than 0, right there. That's pretty much my reasoning. Okay, so back to this problem. Let's take a look at what we got. We need to find a relative maximum. So a relative maximum goes from an increasing slope to a decreasing slope. I'm looking for something like that. So what I want to do is I need to find the critical points and then test them. So need critical points and test them to see if they change, to see if there's a sign change. So let's take a look here. Let's find all the critical points. So the critical points are when f equals 0 or undefined. So let's take a look at our graph again, and it equals 0 at a few spots here. It equals 0 at -4, it equals 0 at -2, then 2, and then 5. So let's indicate all those points. So the critical points are at x equals -4, we said, -2, 2, and 5. Now I'm going to put these on a number line, and I want to test them. So I'm going to make my number line here, and I'm going to test these points. I've got -4, I've got -2, I've got 2, and I've got 5, and I've got these endpoints here at -6 and the other one at 8. So I test the region right between -6 and 4. It is above the axes, so those are positives. Again, it is above the axes right here. Then we go below, then we go above and stay above, then over here below and back above. So I'm going to indicate all that in this. I wish I could have somehow squeezed the graph in so you could see it as I'm doing it, but you can take a look at what I had just done there. So we said that these were above, then from -4 to 2, this was below, so I'm going to put minuses. Then from -2 to 2, it's above the axis, so those are positive values. Then we've got negative values, and then we've got positive values again. So right here, it goes a positive slope to a negative slope. Negative to positive, positive to negative, negative to positive. Which tells me right here and right there are going to be relative maximums. So the relative maximums at x equals -4 and 2. That's where my relative maximums occur. All right, moving on to part D. All right, so for part D, we have to find the absolute minimum value of G on the closed interval. Okay, to find the absolute minimum value, we need relative minimums and test the endpoints. We've already found relative maximums, so from up above, we can find what the relative minimums are. So we need, let's write that in, relative minimums, and the endpoints to test. Okay, so from up above, we can take a look, and we have a relative minimum here and here. So relative min at x equals -2 and 5. So those are my two relative minimums. So that means I need to test x equals -2, 5, -6, and 8. These are the endpoints. And how do I test them? Well, I just put them in the equation. I need g of -2. I need g of 5. I need g of -6, and I need g of 8. Well, I know g of -2 is going to be the integral from 2 to -2, which we're going to change to be negative the integral from -2 to 2. So I'm looking for the area there, and that gives me -2 pi. Again, you can look at the area from -2 to 2, and right here, that's going to be 2 pi. So all of these I'm just relating back to this graph. I have the graph here that I'm looking at that I had printed out, so that's kind of a little easier for me instead of going back and forth. All right, for the next one, we need from 2 to 5. Well, this becomes, again, I'll just show you, from 2 to 5, that's going to be right here, and that's going to be -6. So this ends up being -6. And then I'm going to do the same process at g of -6. This is going to be the integral from 2 to -6, which I'll have to change to be negative the integral from -6 to 2, which gives me 4 plus -2 plus 2 pi, which becomes -2 plus 2 pi, which ends up being, we could say, -2 minus 2 pi. And so far, that's the lowest value that I have. That's less than -2 pi and also less than -6. So let's just test one more. This is going to be the integral from 2 to 8, and here I will get -6 plus 3, those areas in there, and that'll give me -3. So where does the absolute minimum occur? Right there at x equals -6 is going to be the absolute minimum value. All right. So for part E, it says, for what values of x in the open interval is it concave down? So for the concave down, what we need is we need to look at the slopes of f and have them be less than 0. So basically, again, what we're trying to do is we want g double prime, which in our case is f prime, to be less than 0. So we are looking for the slopes to be negative. And if I look up here at my graph, you can see that this will happen between -6 to -3, from 0 to 2, and then from 2 to -3. Notice I have to break this up because this is a discontinuity right here. I can't take a derivative at that point. It goes from a curve to a straight line, so I have to break that one up. So let's indicate that over here. And this will be, as I said, from -6 to 3, -3, union 0 to 2, union 2 to -3. So for part F now, it says find the x-coordinate of each point of inflection of the graph of g on the interval from -6 to 8, and then justify your conclusion. So the possible point of inflections are when g double prime, which is f prime, is equal to 0 or undefined. So I'm going to look at my f prime of graph, which are the slopes, and determine where these slopes are 0 or undefined. Well, there's only, when you look up here, there's only one part where they're going to be, the slope is 0, and that's right here. But all these other points will be undefined. So, because these are discontinuities, so I have to include all those other points. So let's go ahead and put all those in. And so the possible points of inflection that I'm looking at are going to be, thus the possible are at x equals -3, -2, 0, 2, 3, and 5, based on the graph. So I'm going to do my number line method again. There's more than one method. I always like the number line method. And I'll put my two endpoints here, and then I'll put these possibles in between, -3, -2, 0, 2, 3, and 5. And I'm going to test the regions in between. I want to find, this is an f prime, so I need the slopes between -6 and -3, and those come out to be negative. The slopes between -3 and -2, those are positive. The slopes between -2 and 0 are positive again. Just to show you, you can look at the graph and you could see these are over here, negative slopes, positive, 0, negatives. So that's what I'm looking at. Let's finish this up. And over here, I've got from 0 to 2, negatives again, from 2 to 3, negatives, from 3 to 5, positives, and then from 5 to 8, these are positives. So I'm looking for the sign to change. So I need a sign change in the slope. And where does that happen? Well, it happens at -3 right here. It also happens at 0 right here, and then it also happens at 3. So thus, the points of inflection are at x equals -3, 0, 3, since we have a change in sign. Okay, find the average rate of change of g on the interval from 2 to 8. This is a tricky question. This question, you really got to think about it because they're trying to trick you. They're saying the average. Well, we know the average rate of a function. That's 1 over b minus a, the integral from a to b. But we want the rate of change of g, which means this is f. This is g prime. So we are looking for g prime of x dx. So basically, we need 1 over the b minus a, the integral from a to b of our f of x, or f of t, in this case dt. So this becomes 1 over, here are my a and b values, 8 minus 2, integral from 2 to 8. And then this is going to end up being, right, we said f of t dt. So this will be 1 over 6. And what I need here, what this is telling me is I need the area, this integral of f of t, the area from 2 to 8. So this becomes 1/6, and that I'm looking is -6 plus 3. Let me show you the area from 2 right here to 8. It's -6 plus the 3. All right, so this will yield a final value of -1/2. And our last part, h. Okay, it says for how many values c, where c is between 2 and 8, is g prime of c equal to the average rate found in part c. So now it's asking where is g prime of c going to be equal to -1/2. So we need, since it's g prime of c, we really need f to be equal to -1/2. So let me show you what this means graphically. I'm looking at this graph up here, and I'm going to quickly sketch a line where f is -1/2. Let me see if I could do it a little bit straighter here. So this is f of -1/2. So how many times does f, where f is -1/2, cross my graph? And that's what this problem is asking. So right here, 1, 2, 3, and 4. So again, it crosses 1, 2, 3, and 4 times. So it has to cross 4 times, and I've explained that graphically for you. So we needed g prime of c to be the -1/2, which is f to be negative 1/2. We drew our line, so it must cross 4 times. So we can say 4c values. And I've explained it to you because g prime of c needs to be 1/2, which means f needs to be 1/2, and I can take a look on my graph for that. All right, so hopefully this review helped. As always, make sure you leave a like and hit that subscribe button, and I will see you in the next video.